Hey everybody, it's Mr. Clausen. I'm just going to do a couple sample problems here dealing with collisions. So here's a pretty standard problem you might see on a test or homework or whatever. It says a car with a mass of 2,000 kilograms hits a stationary van that has a mass of 4,371 kilograms. The vehicles lock together and then skid to a stop. Analysis of the skid marks show that the vehicles together were moving at 25 miles an hour immediately after the collision. The posted speed limit where this accident took place is 45 miles an hour, and the driver of the car claims that they were not speeding. The question is, was the driver being reckless? Now, this is a pretty typical question that, like, say, an insurance company or the police might be interested in trying to figure out what actually happened at the crime scene. So if we take a look here, we'll set up our problem. All right, so the first thing we're going to want to do here is to identify the important information and draw a picture of what was taking up. So what I want to do here is just zoom out a little bit, put that information up there so we can still see it, but this gives us room to now draw our picture. All right, so we got our car here, and the car's going real fast, so we'll put in the speed lines on that. And there we go, there's our van at rest. And now what we want to do is understand that, something happened after the collision. So we'll draw a little squiggly line right there, and we'll take a look at what happens after the collision. Now we're going to need just a little more room, so I'm going to zoom out just a little bit so we can draw our picture over here. All right, now so after the collision, the car runs into it, hits the van tips up on it, and the two objects move together until they finally skid to a stop. So now we have a picture of what's happening here, and now all we need to do is start filling in the information that was given to us in the problem. So let's start by making our list of knowns. So there's the mass of the car. It had a mass of 2,000 kilograms. And there's the velocity of the car. Now, before the collision, we don't know how fast it was moving, but we do know that the person claims that they weren't going over the speed limit. And there we have the mass of the van of 4,371 kilograms, and its velocity was 0 miles per hour. So after the collision now, we have the mass of the car is still the same 2,000 kilograms. The mass of the van is still the same 4,371 kilograms. And as stated up in the problem, the two vehicles are now moving with a speed of 25 miles an hour together. So now if you take a look, that's all the information from the problem written down for us. We've got to figure out how to solve the problem. So looking at what we got here, I can see here that I've got the mass and velocity of objects moving both before something happens and after something happens. And so what comes to mind here for me is the law of conservation of momentum, which states that the momentum total of a system before an event has to be equal to the momentum total of a system after an event. And don't forget that little apostrophe there simply just means prime or after the event took place. Now what we'll do is just kind of shrink that down a little bit and put that up over here so we can help remember what we're doing with it. So the next step in this problem is start to take a look at what are the momentums of the objects that we have going on both before and after. Now looking for me, it's after the event. It looks like I have all the information because there's not a single question mark there on that side. So that's where I'm going to start taking a look at what's going on. Alright, so to do this here, what we would have to do is we want to take a look at the momentum after the collision takes place. So to find the total momentum after the collision, we have to take a look at the momentum of the car, and we'd have to add that to the momentum of the van after the collision. To do that, you take the mass of the car times the velocity of the car, add that to the mass of the van multiplied by the velocity of the van. And going through this method would totally work. However, I find that it's a little bit more work with your calculator. So what we want to do here is we're going to take a look and do this just a little bit differently. So we went ahead and got rid of that. Now we're still going to find the momentum total afterwards. But if you take a look, we don't really have two objects moving after the collision anymore. What we have now is we just have one bigger object moving. And so that bigger object is the mass of the car plus the mass of the van. But since the two cars are now together, they have a single velocity. I'm going to rewrite that just a little bit smaller and go ahead and put in the mass of the car and the mass of the van. And then all we have to do now is multiply that by the velocity of the two of them together, which is 25 miles per hour. Now if you go ahead and put that in your calculator, you can easily find out that the total momentum of the system after the collision is 159,275. And the units for that would be kilograms times miles per hour. Now, the reason for doing all this to figure out the total momentum of the system after the event happens is, like the conservation of momentum says, the total momentum of a system before something happens has to be equal to the total momentum of the system after something happens. And this question is really about how fast was the car going before the collision took place. Now, to start this out, originally we didn't have enough information, but now that we know what the total momentum is afterwards, we can use that to help us answer our question at the end. So, what we need to do now is start taking a look at what the total momentum of the system would be before the collision. And so we know that the total momentum before the collision has to be equal to afterwards. So how would we get the individual momentum, or the total momentum of the system before the event? We'd have to take a look at the momentum of both objects beforehand. So the momentum of the car and the momentum of the van. Now it's very easy to figure out the momentum of the van because it has a velocity of 0. So since to get momentum, you take mass times velocity, the momentum of the van is going to be 0 because it's not moving at all. This simplifies our problem quite a bit because now all we have is the car's momentum, and to get the momentum of the car, it's the mass of the car times the velocity of the car, and that would equal the total momentum of the system before the event took place, which we already talked about means that it's going to be equal to the total momentum afterwards. So if we go ahead and slide the page up here just a little bit so we have some more room to work with, what we need, we can rewrite this with the information we need and getting rid of the information we don't. So mass of the car, 2,000 kilograms. Velocity of the car, that's what we're trying to find, is going to be equal to the total momentum of the system before and the total momentum of the system after. So in this case, that is 159,275 kilograms times miles per hour. Now, if you take a look here, the only thing we have left to solve for is velocity of the car. So real quick, divide both sides by 2,000. Kilograms. Kilograms cancel out, leaving us with miles per hour. And if you punch that into your calculator, the answer is 79 miles per hour. The original question was wanting to know, was the driver being reckless? And seeing that the posted speed was only 45 miles per hour, which we haven't used that number up until now, it's only as a reference to see were they being reckless. The only way that these two vehicles could have left with that speed of 25 miles an hour after the collision is if the original vehicle had been moving with a speed of 79 miles an hour. And you can understand how that would be an important question for the insurance companies or the police that are trying to investigate. So there you are. There's a sample conservation of momentum problem. The key to the problem is just realizing that the total momentum before is going to be equal to the total momentum after. And momentum is something that's very easy to calculate. It's mass times velocity, and you just add the momentums of the different objects together to get your total before and after. Rewatch this if you need to. Stop in to get questions. We'll see you later.